ladies and gentlemen, we're going to take a look at dilations. I believe this is our last transformation of geometry concepts. And so we're going to take a look at that. So what you want to be able to do is to be able to identify a dilation and then draw dilations from that, be able to find using scale factors. And so it fits quite nicely with similar triangles. All right, so our vocab. A dilation is a transformation that maps points onto a new image based on a scale factor. So it's all of that vocab that I just mentioned. So we're looking at mapping, going from one object to a new object, which means you multiply the length of the segment by a specific value. So if we want to enlarge this, think of like your pupils dilating and contracting. If we want to enlarge it, we're going to multiply by a number greater than 1. If we want to decrease the length of it, if we want to make it smaller, reduce it, we're going to multiply by 1/2 or a fraction. A reduction is a dilation that makes the original figure smaller. And then an enlargement is a dilation that makes the original figure larger. So those two vocab words should be common sense. So let's take a look. Tell whether the dilation is a reduction or an enlargement. What you need to remember is that PQR is our original, the prime is our new. So P prime is our new, P is our original. Here, X, Y, Z is our original. X, Y, Z, X prime, Y prime, Z prime is the new. So if we look at A, the dilation is an enlargement because the image P prime, Q prime, R prime is larger than the original figure, just triangle PQR. And then the dilation is a reduction in this part B because the triangle X prime, Y prime, Z prime, so we're noticing all these primes on the new image, is smaller than the original figure. So I'm hoping you guys can put this, put your vocabulary, your prior knowledge to use, and we should be able to recognize these rather quickly. Now what we want to do is find a scale factor. So what we're doing is taking a look at how far away the original factor, the original figure was compared to the new figure. So we're always doing a ratio of new image to pre-image, new to original. That's where our ratio is going to be. So when we take a look at that, my C to P prime is 2. My C to P is 3. So I have a scale factor of 2/3. The scale factor of the second one, C to P prime, is 6. C to P is 3, and we're going to reduce that down like we would all of our scale factors. And we have a scale factor of 2/1. So what we want to do is we want to take a look at in the follow-up how those scale factors tell us if we had a reduction or an enlargement. So if we take a look at it, the first one is going to be a reduction. Give 2 ways. I'm going to give you the first way. And the first way you can tell is that the scale factor is less than 1. 2/3 is less than 1. You need to come up with the second way. So you need to come up with number 2. This is number 1, the scale factor. So for B, when we take a look at this, it's an enlargement. And the reason I can tell there, reason number 1, is that the scale factor is greater than 1. So your job here is to fill in and find reason number 2, because we're trying to find 2 ways. So I want you guys to think about how we can do that. Reason number 2 is a little bit more of a visual approach to it. All right, checkpoint. Tell whether the dilation is a reduction or enlargement, then find the scale factor. So I'm looking at my P prime. My P prime is farther away from C, so I know that this is an enlargement. All right, because P prime is farther away than P. And so I'm going to compare those two distances. We're always going to do C to P prime over C to P. C to P prime is 10. C to P is 5. And so we have a scale factor of 1. This is going to be on your own. No. So get that done, pause the video, and do number 2. And if we take a look at example 3, we're trying to find the image after reduction, or we have the image after reduction, and now what we want to do are find missing segments of that. So I've got this original triangle, PQR. This is my original. And some scale factor has been applied, and I now have an image, P prime, Q prime, R prime. All right, this is my image. And so what we know is that from Q prime to R prime is 6, and from Q to R was labeled with an X. That's what we want to find. And we know from C to P prime is 8, and C to P is 14. So that's what we want to set up. We know C prime, CP prime over CP would be equal to Q prime R prime over QR. Both these measurements come from the original. Both of these come from the new, the dilation. Now substitute in the values that you know. You know C to P prime is 8. C to P is 14. You know that Q prime R prime is 6. And you know that QR is X right now. We're going to do our cross products. So we're going to do 8 times X. And we're going to do 14 times 6. Multiply, we get 8x is equal to 84. We're going to divide each side by 8. And we're going to get 10.5. And so that gives us our value of X. So if we take a look, they want us to do the same thing here. We need to find the value of X. So let's start by highlighting our original figure here. So here's my original figure. My new image is P prime. And so they want me to find M. M corresponds to 2, so I can have a ratio of M over 2. New to original. I now need to look at what other distance they give me. They give me 20 and 8. Well, C all the way out to 20 is your new figure. 8 is on the original. So this is my ratio. M to 2 equals 20 to 8. If we cross multiply, we have 8 times M equals 2 times 20. We have 8M is equal to 40 when you do that multiplication, and then divide by 8. And we get M is equal to 5. And so what I want you to do is this is your, as you guess it, it's your on your own. And I want you to do now. Have a good evening, and we'll see you in class.